Welcome to Introduction to Cassandra. After watching this video, you will be able to define Cassandra and its suitability for vector search applications and identify the steps involved in implementing Cassandra. Did you know that Meta first created Cassandra and later made it public as an Apache project? Think of a global e-commerce platform managing vast volumes of transactions daily. Cassandra serves as the backbone that stores and retrieves customer data seamlessly, ensuring a robust, scalable, and readily available system. Now that you understand Cassandra, let's explore its essential parts. Nodes act as the first activity level. Then comes a cluster, which comprises a group of nodes that store and handle data. Next, a data center includes a group of nodes in a cluster placed in the same area, allowing data replication across various data centers. Partitioner refers to the part of the cluster that facilitates information sharing between the nodes. Then there's replication. This part of Cassandra ensures that data is always readily available and copies it to different nodes. Gossip Protocol is a decentralized peer-to-peer communication system that allows information to be found and shared between the nodes in a cluster. The commit log is a backup log that records write actions before sending them to data storage files. A mem table is a data structure that allows you to write quickly and is flashed to disk regularly as unchangeable SS tables. Then, the SS tables or sorted string tables. These are fixed-length data files on disk that store data in a planned way based on the primary key. Finally, there is the Cassandra Query Language or CQL interface. This simple, easy-to-understand language is used to connect to Cassandra systems, working like SQL. Now, let's look at the advantages of Cassandra. The first advantage is scalability. The distributed design of Cassandra facilitates easy handling of rising amounts of data by allowing nodes to be added to the cluster. The next advantage is reliability. Cassandra allows for the high availability of data copied across various nodes, thus ensuring no single point of failure. Cassandra also offers high efficiency, as both reading and writing are speedy, which makes it a good choice for real-time apps. Cassandra also offers a flexible data model built on column families and wide rows. Finally, it has adjustable consistency levels so developers can find the best balance between data integrity and system speed based on the application's needs. Next, let's look at some applications of Cassandra. The first application is e-commerce and inventory management. Cassandra is also used for personalization, recommendations, and customer experience. It is also used for the Internet of Things, or IoT, and edge computing. The next application of Cassandra is fraud detection and authentication. In the media streaming and content delivery industry, Cassandra manages user accounts, suggests content, and tracks user data. Cassandra is also used in online learning and education platforms. It also finds applications in cybersecurity and threat intelligence strategies. Finally, Cassandra is used for healthcare analytics and patient monitoring. Cassandra's latest version, 5.0, has been released recently with the following features. The first key feature is vector search. This new version transforms data exploration and analysis by leveraging storage attached and dense indexing techniques. Second, the dynamic masking capabilities allow users to obscure sensitive information using masked columns. Next, the latest version of Cassandra has storage-attached indexes that offer unprecedentedly efficient data retrieval. In this video, you learned that Cassandra is a distributed NoSQL database management system that handles vast amounts of data distributed over multiple computers. The different parts of Cassandra are node, cluster, data center, partitioner, replication, gossip protocol, commit log, mem table, SS table, and Cassandra query language. The advantages of Cassandra include scalability, reliability, efficiency, dynamic data, and flexibility. Cassandra is used in e-commerce and inventory management, personalization, the Internet of Things, fraud detection, media streaming, and content delivery, online learning platforms, cybersecurity, and healthcare analytics.